7-1, so on page 302. And congruent and oblique triangles, if you notice, and the two triangles are congruent, and in geometry you learned side, angle, side, angle, side, angle, side, side, side. Remember that in geometry for congruency? Well, what we're going to do is, if we want to know the length of a side or the value of an angle, there's different things that we can have, and it's actually through congruent triangles, because if you remember that when we do trig functions, it's really everything is related back to the congruency of triangles, because if you have the sine of 30 degrees, it does not make any difference. It's always the opposite over adjacent. It does not make any difference how big, the triangle is in a right triangle. When you have 30 and a 90 degree, then that sine of 30 is always, the ratio of the opposite side to the hypotenuse is always 1 to 2. And if one side is, if the opposite side is like 4, then it means your hypotenuse has got to be twice as big. It's got to be 8. Right? It's always that ratio. The ratio of 1 over 2, opposite over hypotenuse, and it's 1/2. So if the side opposite is 4, then the hypotenuse has got to be 8. If the side opposite is 6, then the hypotenuse has got to be 12. And it's all based on a congruent triangles. So that's what this is, congruent triangles, but not right triangles. The trig functions still apply in terms of sine of 30 degrees, if that's one of your angles, is going to have a ratio 1 to 2. But it's not going to be in a right triangle scenario. So if you look at the bottom of page 302, it's telling you the requirements for oblique triangles. An oblique triangle is just one that is not a right triangle. And it says case 1, you're going to have one side and 2 angles. Now notice you can have a side and 2 angles not including the side, or else you can have an angle side angle. Anytime you have 2 angles, you can always do what to get the third angle? You can always calculate it, can't it? The sum of the interior angles is always 180, so you technically know three angles anytime you have 2 angles given to you. That'll be case 1. That's the easiest one to work with. Then there's case 2. There's 2 sides, 1 angle not included between the 2 sides. So it's side, side, angle. Not side, angle, side, 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 angle. And that's going to have the possibility of having no triangle, 1 triangle, or 2 triangles. And that's going to deal with in 7.2. And then case 3 and case 4, we have side, angle, side, or side, side, side. That's going to require what they call the law of cosines to solve those. Now notice one thing that's missing is if you have 3 angles, and notice that you're getting 3 elements of 6 possible things in a triangle. Let's just draw it out. If I and the capital letter is the angle at that vertex. And then you always list the side that's opposite the angle as a small letter. So this side is A, this side is B, and this side is C. Now, as long you have 6 elements, right? You have angle A, side C, angle B, side A, angle C, and side B. So you have 6 elements. If you have any 3 of those 6, when you have an oblique triangle, you can calculate it. Except there isn't a unique triangle when you have the 3 angles. 3 angles don't make a unique triangle. But if you have 2 angles and a side, any side, or 2 sides and any angle, that's a unique triangle. Does that make sense? Okay. Now they're going to derive the law signs if you're interested in the derivation of it. They're on page 303. If you look at the top of the page there on 303, it says case 1, which is that previous data set, where you have 2 angles and a side, is going to be discussed in this section, and it involves the law signs. Case 2 is discussed in 7.2, and it is going to be the law signs. So notice case 2 is the one in which you can have more than one triangle. You can actually have no triangle that satisfies the condition, 1 or 2. And that'll be in 7.2. And then case 3 and 4, which is from that box on the left-hand page there, is going to involve the law of cosines to do those. So to do side angle side or 3 sides, you're going to have to use the law of cosines. So when you're given data, you say, do I have 2 angles and a side, or 2 sides and an angle, not included angle? And in that case, you're going to use the law of sines. Now the law of sines, once you get through that whole derivation, is just, if you look there at the bottom of the page, it's in that box, and it just says the law of sines tells you that side A over sine A. Notice capital A is the angle, and that's the angle opposite that side, is equal to B over sine B, which equals C over sine C. Now, if you just invert all of those, it's the same thing, right? If you do sine of angle A over that, this first set of statements implies this is true, right? So you use whichever one's convenient. Right? If you invert every one of those, you're going to have that same equality. And they're telling you that's an alternative form. Now you can use any pair of these. You can go A over sine A is equal to B over sine B. Or you can go A over sine A is equal to C over sine C. Or B over sine B is equal to C over sine C. You can use them in pairs however way you want to. And that's normally the way you're going to use it. And what it is, you'll be given data to do it. They're going to tell you there is a way to calculate the area of the triangle, and on page 306 it's giving you the area formulas. Now if you notice that on 306 it says 1/2 of BC sine of A. So BC sine of A. See, it's you got to have this included angle, right? BC sine of A, or it's 1/2 of AB sine of C. It's always the included angle, right? And they're going to tell you that if the sine of A, B, or C is 90 degrees, then it's 1/2 of AB, which is 1/2 of the base times the height. So in a right triangle, that's how you always calculate it. So that's going to be the area formula. So what you'd have to do if you had case 1 where you'd have 2 angles on the side, you'd have to get a second side calculated someplace so that you could use that formula, BC or 8, small b, small c, you know. And that would be possible using the law of sines. So let's look then on page 308 on the exercises. And this is just says consider the oblique triangle. Actually, I got this one, I got it drawn up here just exactly like they got it drawn in the book. That was pure accident, not planned. Now it says consider the oblique triangle ABC. Which one of the following proportions is not valid? So let's just go around and let's just say, take turns and say, is this one valid? And then we'll just find. So Chris, it's up here in front. A, is that valid? The trick is can you write that thing as A over sine A, B over sine B by using algebra?
I would say no.
Well, I think you'd say wrong, because if you would think of this as A over B equals sine of A over sine of B. Now notice that if I multiply both sides by B sine A, B over sine A. You see here it's going to be what? The B's drop out, and here sine A's go out. So my resulting thing is A over sine A, B over sine B, right? And that's valid, right? You understand? I'm just converting it to the law of sines, and the law of sines says this is valid. So that A over B equals sine A over sine B is just taking this thing and manipulating it around algebraically. Does that make sense, Chris?
Yeah.
Okay. So B, Elizabeth, is B valid? Okay, because that is the law of sines, right? So, Lucas, you want to give a shot at C? Okay, not valid. D, how about James? Do you want to?
Yeah.
Yeah, it's just that inverse. It's that what it said, right?
Same thing.
Yeah, that's exactly right. All right. Now then, 3 and 4, it says find the length of side A. Do not use a calculator. Now what I'm going to do is I'm going to show you I'm gonna show you the way I'm gonna express this. I'm just gonna go A, B, C, little a, little b, little c. The way I'll give you the problems is going to be this. So you notice that this capital A is 45 degrees and small b is 10, right? Because that's the side opposite capital B. And then C is 105. And so we have 3 elements, right? And those 3 elements are 2 angles and a side. So what you would do if you were working this, you would say, okay, it's case 1, case 2, case 3, or case 4. It'd be case 1, right? 2 angles and a side. Now, if you were doing more than what this asked for, you could actually calculate all the rest of these using the law of sines. Because you could get this angle by doing what?
180 minus the sum of C.
Right? So you could calculate it by doing this. This B is going to be 180 because why? Why am I using 180? Sum of the interior angles of a triangle is 180. And then I would subtract the sum of 105 plus 45. The sum of the other two. And so that would mean that this angle would be calculated to be 30, if I've done it right. So this you would calculate as 30 degrees. Now using the law of sines, you can calculate all these other things, right? So now normally when you do things, this is what you want to do, is you do not want to use this calculated angle. Just in case these 2 angles are some, rational numbers that have, you're going to get a rounding error. You want to do it with the least amount of rounding error. So if I wanted to calculate A, given this information, what ratio would I use? Okay, I would have to do C over sine C, right? I would have to use B. I couldn't get it without using the calculated, right? Could I? Using the law of sines. Because the side I'm given is B is 10, I would have to use this one. So there's a danger of some, if this were a rounded number, that you could get some rounding error. So I would have to use the B over sine B and get, if I was trying to get A, then it would be A over sine A. So the values I'd put in would be 10 over sine of 30 degrees equals unknown value A sine of, what is it? Sine of A, 45 degrees. Right? So then it would be 10 times the sine of 45 degrees over sine of 30 degrees would equal A. Is that right? And then if I can do this because these are common ones, it'd be 10, and the sine of 45 would be what?
32.
And then the sine of 30 is, and that's what A 1/2. Now, this would invert and multiply, right? It'd be 10 times the square root of 2 over 2 times 2 over 1. So I would have 10 times the square root of 2. And if we didn't want rounding error, this is what we'd put up here.
Before we move on to one of your slides, the very last row that you see on the screen right now, where the sine over sine of 45 degrees goes over, is that just because you can cross multiply?
Yep, that's what I did was I did this. I did sine of 45 on this side.
How you multiply that?
Multiplied the same number times both sides. Because remember, sine of 45 is a number, right? What you have to do when you're thinking about this is sine of 45 is actually a number. It's not an unknown, it's a number. Sine of certain angle is a number, so you can just treat it as a number. If you have a sine of x, then you got a variable. Now I could calculate c if I wanted to, right? I would use the same ratio, b over sine b is equal to c over sine c. And I could find that, right? I'm not going to do it, I'll leave you to do it. But what you're going to see, and the way I'm going to present problems on the test, and I'm not going to give you problems to do before the test because of time constraints. What I'll do is I'll just give you this list, and I'll give you values, and then you'll have to figure out whether or not you're going to use a law of sines or law of cosines, or and how you're going to manipulate the data. Seven one, and once again, I'm going to take the problems from the odd problems in the book. So I would work every odd problem, and especially that 7-2, because that thing is you're going to have to, because you'll see the complication when we get there. Now 3 and 4 is the only one that we can do without a calculator. We'll have to use a calculator to do 5 through 8. So what I'm going to do, because this is what you will see, is I'm going to do 10, because this is the way the problems are going to be presented to you. I'm just going to have this list written down the side, and I'm going to be asking you to solve for each one of these things. And I'm going to be giving you 3 items, right? So in this particular one, they're giving you 74.08. They're giving you B, which is 69.38. Now, anytime they give you see 2 angles, it's automatic. You should automatically say this is the law of sines, because you can always calculate the third. So it's going to be the law of sines. And now they'll have to give you a side. So the side that they're choosing to give you here is 45.38. And I don't care what, whether it's centimeters or feet or whatever it is. I'm not worried about units. We won't have to be worried about it. But now to calculate A, what are we going to do? $180 minus the sum of these two, right? 16. So it's gotta be. Did I do it right? Is it 3654? So now, so this is small c, that's capital C. So you're going to have to use the ratio of what? C over sine C, right? To get these things in your law of sines. Do you see that? I mean, the information that you have, this is the only ratio. This is the only ratio that you truly know is C over sine C. Because that's the only two values you got. You see, you have small c is 45.38 over the sine of 74.08. So now to calculate the A and B, you're going to have to do what? A over sine A or B over sine B. Correct? This ratio is technically staying the same, so if you're really efficient, you'll calculate this ratio, put it in your memory in your calculator, right? And then you call it back up, calculate it out, put it in. Let's see, I'll try to show you what I'm talking about. So at this point, what you could do is you could do 45.38 divided by the sine of 74.08, and now that number is going to be something that you can call back up, right? Twice, because the first place that you're going to use it is you're going to use this ratio where you're going to go A over sine A, and A is what you're trying to calculate, and then sine is sine of 36 point, that's 54. So what you can do, because this thing is going to come up here, multiply, right? So you can recall that thing and do this, right? All you have to do, for this first one, all I have to do is do, I'm pretty darn sure. Did everyone get minus 46.86 something? All right, good. All I'm going to have to do the first time is just do product and do sine of 3654. Close it. And I'm going to have the 42. This was A, right? And I'm just going to round it off at that. Now, I can go up there, and can I go up here, pick that up, enter it, bring it down, and then the next one is just going to be the sine of 69.38, right? Do you see what I'm saying? Then you don't have to put all that stuff in again and again, if you think about it, because this next one down is going to be this 45.38 sine of 74.08, which we've already calculated. And then we're going to use this to do B over sine B, which is B over sine of 69.38. This is going to multiply up here, right? You see what I'm doing? All I'm doing is just being a little efficient with our calculator. You're not getting, did you not get 46?
No,
Did anybody not?
you got 47. All right. Unless I'm in the wrong mode.
Did you, maybe I'm in the wrong mode. Do I have it, maybe I have it in radians. I have it in radians. So I'm not getting that. Jeez. So do you have it in degree?
Yeah.
All right, so that I got a problem there. So I better go back. And do this. 45.38. Oh well, let's just clear this out. 45. And then do the sine, divided by sine of, it's the 74.08 that we want to repeat, right? Sine of 4.08. Okay. Now I can do the first one. I better do it again. And then I'll just take that times the sine of 3654. It's the same process, it's just I didn't have my mode right. So that's 28. I guess you'd probably call it 10, right? Is everyone straight with the confusion that I got? Is that what everybody gets when they get it in that mode? This is A. So I just had it in the wrong mode. That was the error. Hide my face. Is everyone getting that?
Mm-hmm.
Okay, and then we want to go up and we want to pick this 47 up again. And then we want to multiply it by the sine of 69 point, what was that? 38? Yeah. So it's times sine of 69.38. $44.17, I guess. So all I've done is I've taken this thing multiplied across, and I've done times the sine of 3654. And then this one I've just done times the sine of 69.38. Good? Okay. All right. All right. If I just get the mode right. Is that right? All right. So do you see one that you want to do? We could try one of those where we have minutes. There's decimal degrees. We really worked with decimal. I could do like 18, where it's dealing with minutes. So A, B, well, that'll have minutes. Let's do 20. I was looking at 19. I'll do 20, because that'll have minutes rather than, you've already done the decimal stuff. So 7918 C. 79 degrees 18 minutes. And then C is 3981. And then A is 32 degrees, 57 minutes. So the first thing we're going to have to do is figure B, right? So that's 180 degrees minus the sum of A and C, 32 degrees, 57 minutes plus 9, 18. Okay, this is going to be 8 and 7, 5, 1 to carry, 75. That's 111. So this is 112 and 15, right? Right. Then you subtract that from 180. And you're going to have to borrow one. So then this is 45 minutes. And this is 7, 6, 67. Did everyone get that? 67 degrees, 45 minutes.
What was your 67?
I got 67:45. All right. Now, notice the ratio that we're going to have common, right, this is two angles and a side, so it's a law of sines. And so the ratio that we're going to have is the C over sine C, right? That'll be the one that we don't have to recalculate if we do it, right? So we're going to do C over sine C, which is 3981 over the sine of 79 degrees 18 minutes. And then we'll do the ratios of A over sine A. And I'm just going to put the sine, rather than sine of that capital letter, 32 degrees 57 minutes. And what we know that we're going to multiply this times that thing, right? And I'll multiply this out in once. So I'm going to go 39. Oh, this is second math, isn't it? Isn't that where it's at? Second, right here. It's that one. Degree and what did I have? 18. And so I'll just push enter on that because I want to keep reusing that. Is that what everybody got? 40, 55, 51. So that's the ratio. Now I'm just going to multiply that by sine of 3257. Oop, I got 577. Got a few extra minutes there. Okay, I've got everything down right. And it doesn't like what I did. Did I do? Oh, I put that bracket in when I. Oh. I think I got it, don't I? You got 2204. On here, 2204. And then the last one I have to do. It's going to be the B over sine, and that's going to be that calculated thing. So that this one is the least accurate because it's calculated and there's no rounding in there, but if there had been, it would be the least accurate. So I'm going to multiply. Did I delete stuff out so I didn't? So I have to do the ratio again.
Go up one more.
Right there.
Yep. And then just change your angle.
Oh, okay. Smart man. 6745. Yeah. 2040 probably. All right. So any questions on that? It's just a little tedious is what all there is to it. Now what we do is we'll look on page 312, and there you're going to have the area. So you have to use one of the 4 formulas. I'm sure that there's 3 formulas. So if we do look at 48, it's giving you A 34.97. I'm going to do B, C. Let's do C. 3529 on B. And 2860. So. And see, this is two sides and a not included angle. And that's what you need. See, because notice that those formulas on 306, it's ABC, right? It's ABC, it's got to be there. One of the ABCs has got to be an angle, and the other two has got to be a side. You see what I'm saying? On page 306, see the formulas? Those formulas are ABC, right? Two of them are going to be sides and one's going to be an angle. But it's always ABC. You can't have ACB or ACC. It's got to be ABC, one of them angles, the other two sides. You understand what I'm saying?
No.
Okay, do you see the first one? It says BCA. It's an ABC, right? One of them is an angle. You see it on the second one, it's ABC. One of them is an angle. And the third one's an ABC, one's an angle. But you got, the first one has angle A, the second one has angle C, and the third one has angle B. But it's always ABC.
Okay.
That's what I'm trying to tell you.
Gotcha. Okay.
Yeah. Seeing what you look at this, you say, well, I have an A, B, C, right? Two of them being sides. I can use one of these formulas. Huh? Yeah. Because if you had A and an AB, you wouldn't have the right information. You'd have to calculate the C from the A. Understand? You follow what I'm saying? You look at it, so you look at this, you say I got an ABC. So the area formula that I'm going to use is 1/2, and I'm going to have to use the sine of A, so this has to be BC, right? So the formula is 1/2, B is 35.29 times 28.67 times the sine of 34 point, plan ahead here, 34.97. And we just put that in the calculator. So I'm just going to put it in as I think I'm on 0.5, and that'll be accurate because it's a terminating decimal.
Not the way you got it in there.
How did I do that? I didn't put times. Times 35.29 times 28.67 and times the sine of 34.97. Bracket it. 289. So the area is going to be 280. I guess, I don't know, depends on what you want for accuracy. 95. And whatever the units were. All right. So we'll do the ambiguous case for the law of sines, and you can see that there's going to be 4 possibilities when you have that. All right.